Hello guys, so still under vector analysis, I would like us to look at line integrals and now along a vector field. Initially, we looked at line integrals along a scalar field. Now, an arbitrary vector field F is given by, so this is whereby we have I, J, K. Yeah? So vector field, meaning the direction is present. So F of Xi plus F of Yj plus F of Z dz, and our dr is still given by the same. So we want to get the line integral of F, where F is our vector field. Now, from the dot product, we know that if we are getting F dot dr, then coming to dot this and this, the I dot I will give 1. So that's why in our final answer here, we don't have the ij's and k, and j dot j will also give 1. K dot k will also give 1. So this is supposed to be F of zk. F of zk will also give 1. So this is how we evaluate line integral of a vector field. This is how we evaluate the line integral. So we are going to still do the same thing. We are going to express all the parameters that we have, like F. We're going to express it in terms of the new variable, and dx as well. Sorry, this is dr, so dx, dy, dz. We're going to express all of them in terms of our new variable. Now, given a question here, we're being told our vector field F is given by x squared yi plus that. Evaluate the line integral between a is equal to that and a is equal to this. So the solution basically entails us writing the whole of that line integral with respect to the new variables. And our new variables, the curve is given by the parametric equations. X is equal to 4t, y is equal to 2t squared, z is equal to 2t cubed. So what is going to be our value F? So let's start by evaluating F. So F is equal to x squared y. What is our x squared? So 4t squared, y is 2t squared, and I plus xz, so that is 4t multiplied with t cubed of j minus 2y, 2t squared, z is t cubed of k. So what does that give for our value of F? So our F simplifies to F is equal to, this is 16 times 4. So that is going to give us 32t to power 4 I plus the next one, we have 4t raised to power 4 of j minus 2 times 2, 4. So 4t raised to power 5 of k. Done. So we've already expressed F in terms of our new variable, which is t. Now, the next thing is from our formula, we know that we are going to need dr, which is dx, dy, dz. So we can go ahead and express all that in terms of, so let's have this. So we have our x being equal to 40. So we want to get dx dt, we want to get, let's just have all the values here. So x is that, y is equal to 2t squared, and z is equal to 2t cubed. So in getting dx, dy, dz in terms of our new variable, what is dx dt? Differentiating this, we have 4. So dx is obviously 4 dt. Yeah, what is dy dt? Dy dt is 4t. So basically, dy is equal to 4t dt. And what is dz dt? Dz dt is 3t squared. So dz is basically equal to 3t squared dt. So we have our dx, dy, dz with respect to this new variable. Then finally, our limits. So our limits are given in terms of x, y, z. We need to change them to t. So our a is given at 0.000. So our A is given at 0.000. This is basically where X, Y, Z is like that. Now we know the value of X is equal to 4t. So if we replace X with 0, what will be the value of t? T will obviously be, so when X is 0, t will be equal to 0. Let's do the same for Y. Our Y is equal to 2t squared. If we replace the value of Y with 0, then t will also be 0. And finally, our Z is equal to t cubed. If we replace the value of Z with 0, our t will also be equal to 0. So this basically simplifies to t is equal to 0. Then finally, our point B is given by 4, 2, 1. So our point B is given by 4, 2, 1, this being the value of X, Y, Z. So what does this translate to? So we have X is equal to 4t. So when X is 4, what will be the value of our t? Our t will be equal to 1. Our Y is equal to 2t squared. When our Y is 2, what will be the value of t? So t will be equal to plus minus 1, so just 1. And then Z is equal to t cubed. When our Z is 1, what will be the value of t? So t will be equal to 1. T will be equal to 1. So this basically translates to t is equal to 1. Okay, let's now come and evaluate our line integral. So the line integral of the vector field is given by f dot dr, and in our case here we have integral is from 0 to 1 with respect to the variable t. What is the value of our f? So f written in terms of the new variable, we got it to be equal to 32 t raised to power 4. So we have that as 32 t raised to power 4 plus 32 t raised to power 4 plus 4t plus 4t raised to power 4j, this was I, and then minus 4t raised to power 5k. That was the value of our f. Let's just confirm if that's exactly what we had. So minus 4t, yes, correct. Then what did we get for our dr? So our dr with respect to the new variables simply transformed to I4 dt plus j 4t dt plus k 3t squared dt. Okay, fine. So we just check our I, dx is 4 dt, dy is 4 dt. So these are the values here, dx, dy, dz. Okay, now having all that, so we've already written everything with respect to the new variable. So we just multiply and then go on to integrate. So this is going to give us integral from 0 to 1 of, okay, so we have there 32 times 4, so that will give 128, and then we have I dot I multiply with I will give 1, so that will give 128 t raised to power 4 plus, we are evaluating the dot product, j and j will give 1, so 4 will give 16 t raised to power 5 minus k will give 1, 4 and 3 will give 12, and then t will be raised to power 7 dt. Okay, integrating that will have 128 over 5 t raised to power 5 plus 16 over 6 t raised to power 6 minus 12 over 8 t raised to power 8, integral from 0 to 1. So replacing 1, we will have 128 over 5 plus 16 over 6 minus 12 over 8 minus, replacing 0, we'll just have 0. So if we evaluate all that, we should be able to get 26.77 as our answer. And basically, that's how we go about integrating a line integral when you're given a vector field. Okay.